Alright, so today is week 3, and today we will be doing projectile motion. So what are projectiles? Any object that is launched is called a projectile, and the path that it follows is its trajectory. The motion of the projectile is analyzed using its vector quantities, such as position, velocity, and acceleration. When dealing with projectile motion, it is important to understand that motion in 2 dimensions is independent of one another. What this means is that a change in the horizontal vector of a projectile will not affect the vertical motion. Now let's take a look at this picture, for example, the first one. Examine the trajectory of each ball and analyze the similarities and also differences in their horizontal and also vertical motion. Take a second to take some time to look at them and jot down some notes or observations you've made. Now, if you look closely, you can see that even though the yellow ball was launched horizontally compared to the red ball, which was dropped straight down, it still falls at exactly the same rate. And you can tell this by looking at the lines. As you can see, at every position, the yellow ball and also the red ball are at the exact same position, even though the yellow ball was launched and the red ball was just dropped straight down. You can see here, both balls at the exact same position. Here as well. And if you wanted to get more accurate, you could definitely measure it with a ruler. So this is because a change in a horizontal motion does not affect vertical motion. This can be proven by looking at the vertical spaces between the images of the balls as they fall. The space between each ball, so the distances here and here, here and here. If you were to measure those out, they would be the same. Now let's also look at the horizontal motion of each instance of the ball. Now this image isn't that, the image quality isn't that great, so we're going to look at this one instead. This is a image of the trajectory of a cannonball being shot out of a cannon. So as you can see, the change in horizontal distance stays constant between every instance of motion in the green ball. And you can tell this by looking at the blue balls on top. If you were to measure out the distance here, here, and here, if you were to measure out the distances with the ruler, you will find that each space is the exact same distance. So that means that the horizontal velocity of the cannonball, or the trajectory of the cannonball, stays constant. And this is because if there are no forces acting horizontally on a projectile, the horizontal motion will always be constant. And if you were to look at the blue balls, which represents the horizontal motion, and the yellow ball, which represents the vertical motion, you can see that with the blue balls, the distance between each ball stays constant. With the yellow ball, it's changing and it's increasing. This is because there's a force acting on the yellow ball, which is gravity. Now you may be thinking, well, if you were to shoot a cannonball out of a cannon, well, gravity would still be acting upon it, right? So why doesn't it affect the horizontal motion? Well, that's because gravity is acting on the vertical plane, which is why it doesn't affect the horizontal motion of the ball, because they're in 2 separate planes. Now, another important idea to keep in mind when you are dealing with projectiles and their motion is, let's say you've thrown a projectile in an arc, such as this. All right, now I know that the arc isn't very even, but let's imagine that it is. So one important idea to remember is that the final velocity of a projectile, right here, right, the instant before it hits the ground, is equal to the negative of the initial velocity, right, as it leaves the ground. Now, this is true only if the final elevation of the projectile has not changed. So this is the initial velocity, and you can think of the final velocity as just the initial velocity but negative. Now, this only applies to trajectories where the final elevation has not changed. So let's say if you throw a projectile from the top of a cliff downwards, the final velocity would not necessarily be the negative of the initial velocity because the elevation has changed. Now let's do some practice problems. So let's say a player kicks a football from ground level with an initial velocity of a magnitude of 29.3 meters per second at an angle of 20 degrees above the horizontal. Find the total air time of the ball. Now to do this, first, with these questions, what you should always do is draw a triangle out. Like so. That's what you should be doing for the beginning of each of these questions, just to better visualize it. So there's an angle of 20 degrees and a initial velocity of a magnitude of 29.3 meters per second. So let's say you're trying to find the total airtime of the ball. Now to do this, you're going to have to use some trig first. And hopefully you remember some of that, but if you don't, I'll just give you a quick review. It is so, katoa. Note this down if you don't know what it is, because it is very important to remember when you're dealing with questions involving projectiles. So this is sine, opposite, hypotenuse, cosine, this is adjacent, and obviously this hypotenuse, and that is tangent, and obviously opposite and adjacent. So what you're trying to find now, when you're trying to find the total airtime of the ball, you're going to be looking for the vertical velocity. So right now, what you have is, when you're looking at the triangle, what you have is the hypotenuse, and what you're looking for is the opposite side. So as you can see, what you're going to want to use is the sine. As you know, sine of theta, which is whatever angle that we have, is equal to opposite over hypotenuse. Now, if you were to only want to find the opposite side, you just have to isolate the opposite side and then move hypotenuse, like so. Basically, just multiply both sides by the hypotenuse. And there you go, that's how you'd find the vector of the opposite side. Now let's do this for this question. Rho is equal to 29.3 sine 20.0 degrees, which is equal to, give me 1 second. Or actually, instead of calling this just O, I think it would be best to call this Vy, because it is the vertical velocity. So the vertical component of the velocity would then equal to 10.0 meters per second if you were to put 29.3 sine 20 into your calculator. All right, now that you have the vertical component, the initial vertical velocity, the equation that you'd want to use to find the total airtime of the ball is Vf equals to V naught, which is basically just V initial, plus AT. So as I mentioned before, when you're dealing with an arc like this where the elevation has not changed, the final velocity will just be the negative of the initial velocity. So we have an initial velocity of 10 meters per second, so therefore the negative would just be negative 10 meters per second is equal to 10.0 meters per second plus 9.8 meters per second squared times t. And what you're trying to solve for is t. So when you're trying to isolate the t, subtract both sides by 10. Minus 10. And you would get 20 meters per second is equal to, so that should be a negative. Negative 9.8 meters per second squared times t, divide both sides by negative 9.8. And if you do that in your calculator, you would get 2.04 as your time, total air time. 2.04 seconds. Now that would be the total airtime of the ball. Now that you know what the total airtime is, you can find out how far the ball travels horizontally. But before you do that, you need to first find the horizontal velocity of the ball. So currently you only have the vertical initial velocity. So to find the horizontal, if you look at the triangle again, you'd see that the horizontal is the adjacent side. So what you'd have is the adjacent side as well as the hypotenuse. So you'd know that you'd have to use cosine in order to find out the horizontal component. So cosine of theta is equal to adjacent over hypotenuse. And of course, if you just wanted to find the adjacent side, you just move the h over, pretty simple. So it'd be the hypotenuse is equal to the cosine of a. In this case, a is Vx. So we write it out as Vx is equal to 29.3 cosine, whatever the angle was, which was 20 degrees. Sorry, 20.0 degrees, which is equal to, give me 1 second. 27.5 meters per second. Oh, and sorry, I forgot to mention, but when you're writing out vectors or answers to the vectors, it's important to also include direction. Because that way you can be more accurate with your answers. So that'd be 10.0 meters per second up to the right. All right, so now that you have the initial horizontal velocity, since you know that, as I mentioned before, the horizontal velocity always stays constant in a projectile, what you can do is just use the d equals vt equation. Hold on, let me give myself some more space. What you can do is use the d equals vt equation, multiply the horizontal velocity that we have by the total airtime of the ball, and then you get the distance that it has traveled. So essentially, it's d equals vxt. D would be 27.5 meters per second times total airtime of the ball, which is 2.04 seconds. And d is equal to 56.1 meters traveled. Excuse me. So with that, you've found how far the ball travels horizontally. Now, if you were to find the max height of the ball, that's the final part of this question. To find the max height of the ball, you would use the Vf squared equals to V naught squared plus 2AD. Now, this should be one of the equations that you learned how to use in the previous lesson. So the max height of the ball, well, if you were to look at a projectile and its trajectory, you'd see that it reaches its max height, assuming that it is a perfect arc, and in these types of questions, usually it is. You'd see that the max height of the trajectory is always at the midway point. And you know that when a projectile has reached its maximum height, at that very instant, the velocity will be equal to 0. So, using that, you can basically just ignore the other half of the projectile, or sorry, the other half of the trajectory. Now we know that the initial, and oh yeah, you should be using the vertical velocity for this question, because the max height, the distance that we're trying to calculate, is vertical. So when you're using the vectors that you should be using in an equation, should always be vertical if you're trying to look for something in the vertical plane. All right, so we know that at the max height, the final velocity of a projectile will always be 0 meters per second, because at that instant, it has stopped, it is stationary. So we know that that is basically just 0 meters per second squared is equal to, what was our initial velocity again? Vertical, 10 meters up. 10.0 meters per second squared plus, just move this to the side, plus 2 times negative 9.8 meters per second squared times d. Once again, you're trying to find d, so you're going to have to isolate it by, let's first square this out, so this would equal to 0, is equal to 100 plus 2 times negative 9.8, so that is negative, second, so that would be minus 19.6 minus 19.6 times d, so you would subtract 100 from both sides. Move that over there, that'd be negative 100 is equal to negative 19.6 d. Divide both sides by negative 19.6. Negative 19.6. And if you were to put that into your calculator, you would get a distance of 5.1 meters, or sorry, 5.10 meters. It's important to keep sig figs in mind. So 5.10 meters is the max height that the projectile travels. All right, this is another question that you can work on. Now that we've done this, let's look at the same question, or essentially the same question, the same velocity. However, instead of it being kicked at 20 degrees, it'd be kicked at 60 degrees to the horizontal. So once again, draw out your triangle on this one. I'll just let you do on your own. 60 degrees. And that'd be 29.3, so that'd be what your triangle looks like. I'll just let you do this question on your own, using the exact same methodology as we used in this question, however, just with a different angle. I'll just slowly scroll through the notes, just to give you some time to look through it again. All right. Now you can pause the video here, spend some time to work on the second question, or if you feel comfortable with it and you don't need any more practice, let's move on to this one, which is a little bit more harder. Now let's imagine that the ball is kicked at an angle of 37 degrees to the horizontal, and the kicker is trying to hit a stationary object 30 meters above the ball. Once again, we draw out our triangle. Oh. 37 degrees. It's trying to hit a stationary object. Now this object is, let's say it's right up here, that's what they're trying to hit, and it is 30 meters above the ball. Now I'll give you some time to take a look at the question. Try to figure it out on your own. If you can't, that's fine. I'll give the explanation in just one moment. All right, so looking at this question, you may be thinking that there's not a lot of information given. However, because we know that the object that it's trying to hit is perfectly 30 meters above the initial starting point of the ball, we know that the distance that we're going to need to calculate is going to be equal to 30.0 meters. And as well, since it is going to perfectly reach the 30-meter height, we know that the final velocity, just one moment, for the ball to reach a perfect height of 30 meters, it'd have to be halfway through the trajectory. And we know that at the halfway point, the final velocity is equal to 0 meters per second. Yeah, so when you're dealing with these tougher questions, if you're kind of confused at first, it's best to just write out all the information that you know, or sorry, all the numbers that you're given. So we're given the distance, you know that the final velocity, etc. That'd be 0 meters per second. And of course, you know the acceleration of gravity, which is negative 9.8 meters per second squared. So with this, you can find the initial velocity in the equation Vf squared is equal to V naught squared. And you may have noticed that I sometimes write it as the initial velocity as kind of like a VO or a VI. Either way works, just based on personal preference, but they both mean the initial velocity. Just erase that. So yeah, you have enough information to find the initial velocity for the equation, the equation Vf squared is equal to V initial squared plus 2AD. Now you have the final velocity, which is just going to be 0 squared is 0. The initial velocity of, that's what we're trying to find. So we'll have it as V naught squared plus 2 times negative 9.8 meters per second squared times d, which we know is 30 meters. Write that in there. Now what you want to try to do here is to isolate the initial velocity. So basically just subtract everything here and move it over to this side. And you just do that by subtracting both sides. So I'll quickly do that with you guys. Zero would then be equal to V initial minus, so that's 2 times negative 9.8, which is equal to 19.6 times 30, so it's minus 588. Move that to the other side, you would add 588, or 588 to both sides. So then the initial velocity squared would equal to 588. And one last step that we would need is just to square root both sides to get rid of the square. So that'd be, the initial velocity would then be equal to, if you put that into your calculator, it would then equal to 24.2 meters per second. Now, since the distance that you use, this is a vertical distance, you have to keep that in mind. Since the distance is vertical, this velocity that you found here is also going to be the vertical velocity, the initial vertical velocity. So you have to write that as 24.2 meters per second up. So now that you have that, let's just quickly redraw the triangle again. It's kind of a crude drawing, but it's fine. Whatever, how many, that was 37 degrees. 37 degrees. And now you have the initial vertical velocity, which is 24.2 meters per second up. So now that you know this, if you're looking at the triangle, you realized, oh, I need the hypotenuse, and what I have is the opposite side as well as an angle. So with that, you know that you're going to have to use sine. However, this is going to be a little bit different because you are, instead of trying to find the opposite side, you're trying to find the hypotenuse. So to find that, you'd have to write the equation as the hypotenuse is equal to the opposite side over sine theta. And then we can just call this v. Why not? Just to make it so that it fits better into our physics. So then v would essentially be 24.2 meters per second over sine 37 degrees. And if you were to put that into your calculator, the answer you would get is there we go, 40.2 meters per second at 37.0 degrees above the horizontal. And that would be your final answer. Now, the reason why you would write this is because when the velocity that you found isn't just like straight up or straight to the side. It is in fact at an angle. And so to write that out, when you're writing out an answer, to show that it is at an angle, not just straight up or straight down, or straight up or straight to the side, you'd have to write the angle that it is bent at. So whatever this angle is, we'll just call that theta. All right, that'll be all for today. I'll just do a quick scroll through of this question again, if you want to take a closer look. All right, and that is going to be all for today. That'll be the end of the lesson, and thank you for listening.